Ever get the feeling your air conditioner is trying to tell you something? Well, you're not wrong. It has a secret language that communicates its health. And today, we're going to learn how to decode it.
Oh, we've all been there, right? It's a scorcher outside, the AC unit is making a ton of noise, but inside, it's still way too warm. You put your hand to the vent, and the air coming out is just kind of meh. That frustration you're feeling, that's your system screaming for help. It's not just failing, it's giving you clues.
So here's the plan. We're going to crack that code. We'll start with the system's secret language, then dive into this one key metric called compression ratio. We'll see how it totally messes with efficiency, how new digital tools are changing the game, and then the really cool part, how we use it all to figure out what's broken. And finally, we'll look at what this all means for the future. Okay, so how do we actually listen to what the AC is saying? Well, just like a doctor, we need to check its vital signs. And there is one vital sign that is by far the most important. Think of it as your AC's blood pressure.
Now, the technical term for this blood pressure is compression ratio. All it really is a number that tells us how hard the heart of the system, the compressor, is working to pump refrigerant. And just like with our own blood pressure, if that number is way too high or way too low, it's a huge red flag that something is seriously wrong inside.
Understanding this vital sign all starts with a pretty simple calculation. But, and this is a big but, there's one tiny detail that can throw the entire diagnosis off track if you get it wrong. Here's the formula. It's just the absolute discharge pressure divided by the absolute suction pressure. Looks easy, but that word absolute is everything. It's the secret password, and it's where a lot of folks mess up. You see, the gauges a technician uses, they measure pressure relative to the air around us. But to get the real absolute pressure inside the pipes, you have to add the weight of the atmosphere, which is about 14.7 psi. If you skip that step, your math is basically useless. So remember, always convert to absolute. So why are we obsessing over this one number? Simple. It's directly tied to how efficiently the system is running. And let me tell you, when this ratio gets too high, it's putting the squeeze not just on your system's performance, but on your wallet too. Check this out. It's a totally backward relationship. As the compression ratio climbs, the compressor is under way more stress, but the amount of cooling it can do actually goes down. Think about that. It's working harder to do less work. That's just wasted energy, and you're the one paying for it. A lower, healthier ratio, that means less stress and maximum cooling power. But here's the kicker. A good number isn't one size fits all. A super efficient home AC should be chilling in that 2-to-1 to 3-to-1 range. But a commercial freezer, that thing's got to work way harder, so a ratio of 13-to-1 could be perfectly fine. It's all about context. Now, for years, techs had to juggle all this math in their heads out in the hot sun. But not anymore. Diagnostics are going digital. We've got software now that acts like a brilliant system detective, doing all the heavy lifting for us. Tools like the MeasureQuick app just automate the whole shebang. It pulls the live data, it does the math correctly every single time, and here's the real game changer, it profiles the system. The tech just tells it the model, the refrigerant, and boom, the software knows exactly what the compression ratio should be for that specific unit on that specific day in that specific weather. The software then takes that number and rolls it into a simple, easy-to-read health report card called a vital score. And you can see right here, compression ratio is a huge piece of that pie. If the ratio drifts out of that healthy zone, the score drops. An alarm bell goes off instantly. No more guesswork. All right, now for the fun part. Let's see how this all comes together. Because with the right data, the compression ratio doesn't just give you a number, it tells you a story. It's the key to cracking the case of what's actually wrong with a failing system. So let's say the app flags a ratio that's way too high. Maybe it's sitting at 4.5-to-1 on a system that should be down around 2.8. That is a crystal clear sign that the system is under an insane amount of stress. It's like it's trying to run a marathon while breathing through a coffee straw. A high ratio usually points to one of a few usual suspects. The number one culprit? A dirty outdoor coil that literally can't breathe and get rid of heat. But it could also be too much refrigerant in the system, some kind of blockage, or even air that's gotten into the lines. All these things make that compressor work way too hard. Now, what about the opposite? The ratio is too low. You'd think, hey, low is good, right? We want a low ratio. Well, not if it's this low. If it drops below its designed floor, it can actually be a sign of something much more catastrophic.
It means the compressor isn't even building pressure anymore.
And this is the diagnostic money shot. When the software sees a super low compression ratio and a low electrical amp draw from the compressor at the same time, it's an open and shut case. The motor is getting power, but since it's not drawing many amps, we know it's not actually doing any work. The guts of the compressor, the valves, the scrolls, they're toast. It's a fatal diagnosis, and finding it this fast saves hours of painful guesswork.
Having this kind of diagnostic power is changing the entire industry. Seriously, we're finally moving away from just fixing stuff after it breaks down and into a whole new world of predictive maintenance. And the key to this whole new world is something called benchmarking. It's pretty simple. When a new system is installed or serviced and it's running perfectly, the technician takes a digital snapshot of all its vitals. It's like a birth certificate for the system's health. So check out how this plays out. On day 1, the system gets a perfect benchmark score with a healthy 2.8 to 1 ratio. A year later, a tech comes back for a tune-up and sees the ratio has crept up to 3.4 to 1. Now, the AC might still seem like it's cooling okay, but that rising number is a data-driven warning sign. It's telling you there's a problem, like dirty coils, long before it causes a complete breakdown on the hottest day of the summer. And the tech just keeps getting cooler. There are now non-invasive methods that can estimate all of this, the pressures, the compression ratio, using just a few super-sensitive temperature probes clipped to the pipes. You can get a quick health checkup without even hooking up gauges, which means no risk of tiny refrigerant leaks. So, what does this all boil down to for you and me? It means we're finally learning to speak the language of our machines. By understanding and tracking this one single number, the compression ratio, we can stop being surprised by breakdowns. We can move from making that frantic, sweaty repair call to predicting and preventing failures before they ever happen.